Hello and welcome, ladies and gentlemen, to PASCO Laboratories. We're here, we're live, and I'm JP. And a lot of people ask me, what does the P stand for? Roger, you've known me for a long time. What does the P stand for?
Persevere, maybe preservation.
Maybe preservation.
There we go.
Because it's Earth Day. And so we want to wish everybody a very happy Earth Day. It's a great Earth Day. The P stands for preservation. My parents were thinking in advance for Earth Day, and we are thinking, what are some good things about Earth? And of course, we've got some beautiful plants here, and plants are a good part of the earth, and of course we couldn't be alive without them. And so we think a lot about plants and kind of some of the things that happen on Earth and our planet. And let me ask you guys at home some questions. In fact, this is a great opportunity to be live, and we can kind of see what you're chatting and what you're saying. So get close to your keyboard and get ready to answer, because I'm going to ask you a couple questions. So let's see how quick or how good you are with some very simple questions about plants and Earth Day. And then we'll check with Roger, who is our plant expert, by the way, to come up with the answers. And so question number one, how many elements do you think it takes to grow a plant? How many elements do you think it takes to make like what I see right in front of me here? Type in your answer, and I'm going to turn to Roger, and I'm going to say, Roger, how many elements do you think it takes to grow a plant? Your answer is?
3, 4, 5, 10. Let's just go more than I think. How about 14?
14 is a good guess. It's a little bit higher. It's actually 17. Oh, wow. There are 17 elements that are required to grow the plants that you see in front of me. Of those 17, 3 come from the air. Now, I'm going to ask you at the end what those 3 are. So you'll be thinking at home, I think one of them is going to catch you off guard. 2 of them are quick and easy, but one of them you got to think a little bit about. But 3 come from the air, which means 14 of those elements come from the soil. 14 of those elements come from the soil. Now, let me ask you some true or false. You recognize this element?
I do.
What's that element?
That's tungsten.
Okay. True or false? Tungsten is an element that's required for these plants. What do you think? True or false? Type in your answers at home. Roger, true or false? Tungsten for plants.
It's just too rare. I'm going to go with false.
And false is the correct answer. Good for you. Right. Tungsten is not used. Let's check to see how much you know about your other elements. Let's try this one, Roger. You know Mo?
Ooh, molybdenum.
Molybdenum. Molybdenum. Right.
Ooh,
so,
yes.
Right. Can't pronounce it, but I'm asking you, true or false? Molybdenum is used in plants. What do you think? True or false?
I think it is, yes.
And I think you're correct. That's why you're the plant expert, Roger, and hopefully you got this correct at home. Molybdenum is used in plants. In fact, molybdenum is used in a very important process that converts a very important element into the things that are used for plant structures. And what do you think that very important element is that molybdenum helps convert into the proteins that make plants and fiber? What do you think that element is, Roger?
It's got to be, let's go with nitrogen.
You're absolutely correct. It's nitrogen. Because there are 3 very important elements that make up most of what's here in plants. And of course, those are the 3 elements that show up in fertilizers. And so when we take a look at my fertilizer here, you'll see here there are 3 numbers on every fertilizer that you buy. In this case, you see a 24-0-11, or you see a 5-10-15, or in this case, you can read the numbers right off of this one. It says,
yeah, there's an 855.
Right, 855. And so these 3 numbers are actually telling me the percent nitrogen, the percent phosphorus, and the percent potassium. Nitrogen is number 1. So 3 very important elements, nitrogen, phosphorus, potassium. And that's great because nitrogen is an element that's found in so many things. In fact, it's found in the plant structures here, but it's also an essential element in all proteins. So when I'm talking proteins, I'm talking animal protein, plant protein, the things that you eat and the DNA that makes up our bodies is all based on nitrogen. So nitrogen is important, but you might know, as we all do, that nitrogen is a gas. In fact, 78% of the air is nitrogen. So how does it get from a gas to a solid? How does it become this? Well, the answer is some very crafty little bacteria called nitrogen-fixing bacteria that take that gas, turn it into the nitrates that are in the soil. And so you might be celebrating at this point and saying, hey, nitrogen is great. Nitrogen can be, can't it?
Gas, that's right.
Nitrogen can be very good. And so I'm going to be good nitrogen, and we're going to do a little acting. You ready to act?
That's right.
Okay, because we're going to make Roger bad nitrogen. So I'm good nitrogen. So let me bring up my picture. Hi, I'm JP and I'm good nitrogen. I'm found in proteins, I'm in your DNA, I am great for nitrogen fixing bacteria, which is part of the nitrogen cycle, and I make plants grow, and I'm just beautiful. Everything about me is good.
But as in all good things, if you take it to an excess, then it just gets to be a bad thing. And that is if you're putting nitrogen into the soil and you put way too much in there from fertilizers or other kinds of materials, it ends up really washing out quite quickly. It isn't available right away. It just keeps moving on. And if it gets into the waterways, it's going to encourage the plants to grow there, like the weeds or the algae and that kind of thing. And eutrophication happens as they crowd out the sun and they die at the bottom and they consume all the oxygen. That is not good.
That is not good. So we talk about nitrates as being good, and we can talk about nitrates as being bad. We recognize that they both have an implication. And one of the great things that we're going to show you now is that you can actually go out into the field, out into a stream like Roger did here, and measure the concentration of nitrates available in the soil. And you can do it so quick and easy, and you can do it using some maps and GPS that you can then take a look at global issues when it takes a look at nitrates, and that's what Roger's going to show us now, right?
Yeah, absolutely. And first, I'll just say again, happy Earth Day. I'm excited about that because 51 years ago, when we started in 1970, my mom was quite an activist and had said, hey, let's as a family go out and help for this first Earth Day thing, and we planted a bunch of trees. That tree is still standing. It's the middle of the A in the word Bismarck in North Dakota, where I grew up.
Awesome. And, 51 years ago. How old were you, Roger?
It's still there.
Were you?
I was quite young. Yes.
20?
And so,
we'll come back and check on that number.
Exactly. But I will tell you that kind of activism or getting students out, it makes a remarkable influence. And I do remember it even to this day and continue to point out those things when I talk to students. So getting some of the instruments that we have to get students out and measuring things like temperature. I mean, heat alone can be gathered in places like big city and concrete areas. pH can change because of our traffic. Weather itself can be influenced because of those changes, conductivity and salts that end up in water. So all of those are instruments that we have and can engage students that will help them remember things like an Earth Day if you get them out to do that. But we're going to focus on water. And so what we have is a colorimeter. The colorimeter is going to be the device that we use, and we use some kits that have just a pre-mixed amount of chemical in them that react inside of water samples you might gather from the river or from a creek or a pond. And we're going to go ahead and pour those into a source and check those. But
so Roger, you're using our standard colorimeter. Now this colorimeter
right.
isn't just the water quality colorimeter. This is a colorimeter that can be used for a lot of things in the chemistry lab.
That's correct.
In the biology lab.
Yeah.
But it can also be used, I think, with one little
addition.
Change, one little addition. Your regular colorimeter that can be used for Beer's Law for concentrations of solutions can become a water quality colorimeter with the use of these nice little Snap Vials. So,
right. And so what happens is that these pre-mixed amounts, we're going to show how we kind of mix those, can be put into that same space. They're 1 centimeter in diameter. They fit nicely into the cuvette holder of the colorimeter, and then you just need to block out light somehow. And because they're taller, we've added a little bit of a shade that goes on top to keep that light from goofing up the how much light gets absorbed by these. You can see, just as this example, here's a nitrate set of solutions that get stronger and stronger, and as you get to the end, you can see it gets darker, and that's the concept that we're going to do. But when you get out there, how do you set it up so that you can use something as simple as your own phone and then connect to the colorimeter? So all you'll need are these two things and some snap kits, which will come into a container like this kind of size. And the directions are all in there. But let's take a look and see what we have to do to set those up. Before we do, I will mention that the government does measure these things, and this is today's readings for nitrates. You might notice that around in the big growth areas for corn or wheat and those kinds of areas have more nitrate, or maybe the Central Valley of California. And it's important to measure those. And in some places, over 10 parts per million is what the legal drinking limit for those are, so that you don't have to treat it in some way to get rid of that nitrate.
So in these areas where they're actually monitoring that, if you get above 10 parts per million of nitrates in the water, then that's considered to be too high.
That's correct.
And we're able to measure at that level.
Correct.
With this kit here.
Yes. Most places it'd be rare to run in those, except in those kind of growing areas. Generally, the chemistry that goes on here measures it up to parts like 4 parts per million. because that's the chemistry is most stable there. But with the instrument, as opposed to just looking at it by eye and color comparing it, we can extend that range a little bit. And so there is an optimum range, which is 0 to 4 parts per million, and our spectrometer does extend that just a little bit.
That's excellent.
So what you'll need in terms of your phone is just a small app that's free and you can download on a mobile platforms like your phone. It's called SPARKvue. When that opens up, you're going to see that there's a starting page that will say, hey, let's set up a sensor which we're going to connect. And as a matter of fact, I did this so it would see what it looks like if we're down by the creek.
So you've got a little video of Roger actually going down and collecting the water sample and taking a look at it. Correct, Roger?
That's correct.
Okay,
let's
send Roger down to the water.
On your phone, you'll just click that to start it. It's an app that you can get from your app store. You're going to choose the sensor type here. All right, on here it's going to have one default check. So we're going to uncheck those guys. And below we're going to choose instead to look just at the nitrate levels. So you're going to just check nitrate levels, and I want to get the GPS signal, so let's turn that on as well by hitting that little button that comes on, and we'll choose latitude and longitude. I'll go ahead and choose to see a table just so that I know I'm getting the data I need while I'm out there. Okay, so I have a table and a graph, and inside of the collection type here, I'm going to choose manual mode. Oop, hold on. It says mixed, and I'm going to choose up here manual. Okay, last step we want to do is calibrate the colorimeter, and you can see where it says nitrate here. I'm going to click on that nitrate and say calibrate sensor, and right there you're going to put a clear solution into here, that comes with the ezSnap kit, and you're going to then just come in and say calibrate, and once you've hit that little check mark is there. Now you're ready to test your solution. You'll put it inside of this unit, and when you're ready you'll start, and you'll see there's a little green check mark that all you do is when you're ready and you get to your new site, you're just going to say, oh, I want to collect that site based on what's being absorbed here. We can hit that. The other place you can hit it is right down here at the bottom, and that'll save a spot, and then you bring your data back. You can share it right to your computer through the share function. All right, I see that while we're watching this, we have a question that's come in. Nolan, do you have that question for us?
Yeah, the question was, can this measure colloidal silver?
If you're looking for dispersion, which things like colloidal silver, I think you would measure it through the turbidity, which does have a function. We don't have it built in that way, but you could measure the turbidity if it's getting more and more cloudy, because it is a turbidometer. I think that was the nature of that question.
I would think if it's colloidal, it would be turbidity. Again, it's not set up, so there isn't a range specific set up for this, but since it does measure different ranges at the different wavelengths, you would capture that.
You'd set up a calibration curve from some very low concentration to higher, and once you get that curve, then you'd just put your sample in, and you'd measure it off that curve, which is completely possible inside of the SPARKvue with this turbidometer.
And then through an application of Beer's law, you would just then find the concentration of your unknown solution.
Yep.
Excellent. So Roger, you went down to the stream, you collected that. What we didn't get to see is how you actually did the actual science behind the capsule and whatnot. Could you show that?
Absolutely. So I've taken a sample of the creek water. I've poured in my pre-measured amount, which it just described how much you need. What you're going to do is use your pre-mixed packet, which I have off to the side. It's a zinc kind of a compound that goes in. I'll pour that in. And you got to shake this for a minute. And again, read the directions because I'm just going off the top of my head. I mean, I've done lots of these.
So I can join you in
that's
this.
right. We can do a little shaking here as we're going. While we're doing that, I'm going to put the couple of drops of the acid that fixes this into, here, I can give that to you so you can keep shaking that. Mm-hmm. And put again, those directions are included in the packet. And what this will do, the zinc is going to help to catalyze what nitrogen is in there so that it's in a reactive form. And then we're going to go ahead and mix that with the acid so that when we mix here's our pre-mixed chemicals in this little vial. And I'm going to say we're probably just fine in terms of our illustration purposes. Again, follow the timing on there is nice. We're going to take that catalyzed sort of solution. We're going to pour it out, leaving the zinc behind on top of that fixing solution that was in there. Okay, now those have completely been mixed in, and it's at the bottom. As a matter of fact, if you want, you can stir that up just to make sure they're nicely mixed. This has got a very sensitive, sort of fragile glass tip, and at the bottom there's little curved scalloped edges on that. And so I'm just going to put them into that little scallop, or that little half circle, as you can see with that shot there. And I'm just going to grab the top and pull it towards myself. So let's go ahead and pull that in. It will bring in the amount of water that's necessary.
Oh, that was quick. It just snapped off the bottom.
Yep.
And
there's a little bubble to help.
Vacuum in there, and
exactly.
So it sucked it right up in there. And
then it does take about a minute to develop. So we'd put it in here, and you'd compare it either to the colors, visibly. They come with color compare that. Well, they don't come. You can, some kits that this company that we use to buy them from does do a eyeball sort of method. And then what we're doing is saying, hey, at the time that this is getting really light, because there isn't that much nitrate out in the water, we can put it into the spectrometer, and then right from SPARKvue, it will read that in parts per million, which is the common way of nitrogen. Parts per million nitrogen is what you're going to get as a reading out. Again, 0 to 10 is sort of the acceptable. If it's over 10 in the EPA sort of standards, it says it needs to be dealt with. So that is going to give us those kinds of values. Now here, after yesterday, I just went out to the creek and I ran well, I didn't run, but I went to several spots along in the creek. And you can see in terms of the map, there's small dots that are on there. This is inside of our program. We have a map function. What's cool is that because we turned on the GPS and it was using the phone GPS, not another probe, but just the phone GPS that's built in there, it was saving the location, plus it's reading the value. The blue values are around 3. You can see in the bottom right corner, there's a little scale that tells you what those values are. And the red values in the middle of town, there are higher values, about 7. And that's not uncommon. We see another creek that's coming into, there's a left-right sort of creek that's running as it's coming out of the mountains, and then there's another small creek coming in as a 90 degree from the south. And that possibly is a source of where some fertilizers may be coming into the creek itself.
That's interesting. So I'm looking at the, kind of with your pointer, point out where those dots are. Like where's the stream? Where are the different points that you measure?
So this very first one is where PASCO is, and the stream sort of runs this way. And I just went to places where I knew
so
the
these
roads
dots are blue,
crossed.
and so they were low, but then it turns red at higher concentration. So we are actually capturing some nitrate infusion, maybe some runoff from fertilizer possibly coming in.
Yards or a field maybe that has like a school's yard or a golf course. I mean, they can be all sorts of, and it can be very short time where it's just a little rainy event or somebody's water turned on and washed it, out.
I see, and we just capture that. Very nice.
Yeah. Now, what's cool is that not only inside of SPARKvue can we have that data, but if you are inside of your phone app, I can hit that upper sort of, it looks like a sideways V. That's the share function. And if we want to share data, I can email that data back to myself. I've put it in the email function inside of my phone. And that gets sent back to my computer. And if you're working on some other platform like a computer, you can just go up into the file and you can save that whole file as well if you want. But you can export just the data as a text file.
And when it exports it, it's giving the data in a standard file format, correct? It's CSV,
correct?
Right? Comma separated values.
Right. It'll be a table saying, here's your latitude, here's your longitude, here's what the nitrate value was, and any other instrument that you were hooked up to on your phone, whether that was, any of those probes we talked about at the beginning, is taking the GPS and marrying those together. So now they're a single file.
And you could use that, by the way, if you were using Excel, for example. You could open that file in Excel and do some Excel work with it in your Microsoft suite if you'd like, but then you're also able to use it with ArcGIS.
Right, and if you want in a free account, that you just go off to arcgis.com. It's an online mapping interface. You can literally, you can see in my file in the bottom corner, it's sitting on a folder in my computer. I'll drag it into sort of the older format that's there. They're going through some soon. I know they're going to have a little update, but that's still fine and it's working great so far. I'll go ahead and put that into the computer, and what will happen is a pop-up will say, oh, I see you have something called latitude and longitude that you have to find and say, use those two fields. On the left side, you see all the column names, stuff like what's the red absorption or the nitrate or things. Find the one that says latitude and longitude, and if you tell the computer, use those two numbers as latitude and longitude, what you'll get is, and I've already shown you the nitrate values across town, so here's a different sort of a map. Here was pH as I drove across town on a rainy day, and you can see that the pH was getting higher in some places and lower in others. If you look.
This is very nice. So here you're using, in this case, you're using the pH probe.
Yep.
Again, connecting with your phone.
Yep.
Using the GPS within your phone, dropping that into a standard map with the help of Esri, and we're able to take a look at this data.
Right.
And here we see some different values here too.
Yeah, anytime you see two big highways cross, all that carbon dioxide coming out from cars is going into the water from the rain, and it's causing the water to become a little more acidic. And in areas where there's more city and there's more green, as you see, then you see that it's less acidic. It's more basic, or more even towards neutral, I'd say, the blue kinds of areas. Not only can we do that, if we're in an Esri map, we can have some other functionalities that we don't have, like come back again in another time to add data to those. That takes a little bit of work if you're a GIS person or using ArcGIS Online, that you can combine one test with the next time you come in the fall or the spring, and you can make a different kind of a graph.
time lapse almost.
Exactly.
We can see what happens over time and plot that data
Yeah.
and monitor that data.
So this little river that you see here, you're seeing the first three on the left side or the west side of that creek. They're very low in salinity. Here's now a conductivity sensor, and then on the right side they have like 5 or 6 times the conductivity or the salt that's in there. And that could be a different way that you've got even more functionality to help your students tell cool stories. What was nice is that our students were able to then ask the computer, the stored area inside of GIS, hey, do you have like government aquifers, for instance? And you can see 3 different aquifers running through that same river. Or did somebody go off and catch some like macroinvertebrates, the insects that live there as well? And you can add those on top. So they didn't do that work, but they leveraged other people's work that was there.
Awesome. So you're able to go in and just pull maps of different types of data and lay it on top of the map of your data. And now you've got layer upon layer upon layer of data, some of which you collected, some of which somebody else collected, all of which can be combined to tell a story.
Right, and so as your students realize that science is really a collaborative process, they can share what they measured, and they start to understand it has a meaning and it has significance. And that was what was so important at that first Earth Day, that I left a tree that's still standing, that your students can go out and do some great work that has a cool story. And so, you know, it's good for the students to grow in understanding. If they understand those areas, it'll, you know, about bugs and whatever else is in there, it may help out the ecosystem in terms of them caring for it and making, you know, plans to help. And students just love getting outside to do science. And so any variable you measure can make a difference. And I think that's what's so fun about this and Earth Day, so that you can get your students out measuring things, and we can, you know, really engage students so that they get an appreciation for what this Earth is about.
The nice thing is, Roger, it's not just students that like to get outside.
As teachers, we love it as
I
well.
love to get outside too, so I don't know who you're fooling. It's always good to get outside with the students. And the one thing that's capturing me here, there's been a lot of discussion of like big social issues that impact a variety of things, from farming to living situations, to weather, to some of the things you've already mentioned. Big social issues can be captured this way, and just by collecting some very simple data like you did here with nitrates and layering that on top of some of the other data that's been collected, we can actually start taking a look at local, regional, global impacts, and really starting to analyze some of these big social issues that people are talking about. So it's not just something small, it can become something very big.
Right, not only do you understand what your measurements mean in a context of a bunch of other measurements of the same kind, but then they also have implications, like you were saying, in things like demographics, or in the, you know, the economics of an area, or, you know, just what businesses, and they can be exciting things like, hey, if we have more of these, like the students that did the bug study, wanted to tell those in the area you could come fishing there because the macroinvertebrates were healthy and they were available.
And fishing could actually help the economy
That's
in that
right.
area and bring people in,
That's right.
which then is part of the economy. So if you're looking to solve like big problems, little problems, or even just analyze some simple stuff, this is a great way to do it. Our partnership with Esri and the way that we're able to connect some of our simple things here, like the water quality colorimeter, the colorimeter with the water quality attachment, or any of our devices, allow you to go out and measure anything that's measurable out in the field.
And this is really almost a new announcement. I do want to point out that we're using the GPS that's in your phone. Before you had to have a probe of ours, like our weather sensor, that had a GPS in. Now we're saying, hey, let's just grab the GPS in our phone, and any of our sensors that you want to use will have location with them, and you can get your students doing these kinds of Earth Day projects with pH, with colorimeter.
Only for people that have phones.
That's
and there's
true,
only
that's
a
true.
few of those.
Just a couple of your students probably have a phone.
Right. So anybody with a phone now, they can connect to GPS and they can start doing this analysis and dropping that into Esri in the different layers. And so I'm excited. It is Earth Day, and it is a happy Earth Day, and it's a great way to connect our students with ways to take a look at global things, and I'm thrilled about it. Before we finish up, I'm going to come back to that question, Roger. I said you could get 3 elements from the air.
I thought you were going to leave it alone.
No, because there were 17, 14 from the soil, 3 from the air. You've been thinking about it for
I
the
have.
whole time, and
And
I
I've
know
been
you folks at home have been also, so type in your answers now, because Roger's going to reveal the 3 elements. Shout them out at home. I'm listening. Roger,
Okay.
they are?
One has got to be nitrogen, because we've been talking all this
From the
time.
air?
It's nitrogen.
No.
What?
No, nitrogen's in the soil with the nitrates. No.
But
no.
nitrogen in
no,
too?
No.
Okay.
No.
I have to go with oxygen.
Oxygen is one.
Okay. Carbon dioxide.
Carbon dioxide has carbon and oxygen,
Yes.
so I'm going to give you carbon.
Okay.
So that's 2. We need one more element. This was the tricky one.
From the air.
Yep.
And not oxygen?
Well, we already said oxygen.
Okay, yeah.
Give up?
I have to.
Did you give up at home? It's
You
hydrogen.
probably-
That's
Oh,
right.
of
So
course, for
carbon,
water.
oxygen, and hydrogen. Right. It's all right there in the air, and it's all available, and that's what plants take in. And that's the 17 elements that make it, and that's the 17 elements that made our show today. And so, from PASCO Laboratories, I'm good nitrogen.
I'm the bad nitrogen. But
And-
have a great, happy Earth Day.
Absolutely. And we wish you, as always, the best of luck, great teaching, and good day.